Hello all. All right, we are going to jump right into the first part of this topic, topic 8. Now we're going to get into climate. So when we think of climate, right, we always mention climate with weather. Climate is not weather, it's related to weather. It's all of those weather conditions, but now we're talking about a long period of time, 10 years to 1,000 years, if not even longer. So when we think about all of those weather factors that we finished talking about what feels like forever ago, now we're just talking about all of those things on a really big scale. Okay, so many years. Now, the next couple things are going to be all different ideas that go into affecting an area or a region's climate because it's never just one thing. All right. So when we think of the temperature of an area, there are two important characteristics. The first thing is the temperature over a year. Okay. If I was to ask you, what is our average temperature here in New York, right? Most of you, of course, are going to say cold because that's what we love to say. But no, we don't have a cold temperature. We don't have a cold climate, right? We have an average temperature, right? We are not hot all year. We are not cold all year. So an average temperature over the whole year, right? The second thing is going to be the range of average monthly temperatures. So when we think of this, what month comes to mind when we're talking about the coldest months? What month comes to mind when we're talking about the warmest months? And when we put them together, we get what is known as the annual temperature range. All right, so that goes into both the average temperature over the year and the range of average monthly temperatures. That is known as the annual temperature range. Next, we have moisture. Okay, well, we know moisture is referring to the amount of water that's in the air, but there are two different ways that we describe that type of region, right? If an area is arid, right? Some of you remember the deodorant, arid, extra dry, right? An arid region is an area that is going to be dry. Now, what does that mean? Well, we have to remember that in terms of something being dry, there's going to be less yearly precipitation than there is evapotranspiration, meaning there is less water coming out of the air than being being evaporated up into it. All right? And when you think of this, the first region that usually comes to mind is a desert. Very little rain, very dry. All right? Deserts, tundras. Okay, so evapotranspiration we talked about earlier already, right? It's the combination of evaporation and transpiration. So we want to make sure that we include that because plants pull the moisture out of the ground and also will release it to the air. Next, we have humid, right? Humid referring to moist or wet. Okay, so if an area is humid, it's going to be the opposite of an arid region. So a humid area is going to be a place or a region that's going to have more precipitation than it does evapotranspiration. Okay, now that doesn't mean that you're not going to have a lot of evapotranspiration. It just means that there is more coming out of the sky, making it a very wet region. So, first place that comes to mind, rainforest, right, or a jungle, right? Those places are going to be very wet all year long. Okay, so we've pretty much talked about these two questions. What type of place on Earth would you have an arid climate? Deserts, because we have a lot more evaporation than precipitation, right? And number two, what type of place on Earth would have a humid climate, right? And why a rainforest, more precipitation than evapotranspiration. Next, that brings us to latitude and temperature, okay? Now, this is something that should make sense. If I was to ask you, where would you go on Earth to be cold all year long? Every single one of you are going to tell me the North Pole, possibly even the South Pole. And then, where are you going to go if I asked you if you wanted to go to a place that was warm all year round? You would tell me the equator. So that's what we are referring to. And latitude is going to affect, all right, both the temperature and the moisture of an area. So our low latitudes, meaning tropical regions, right? The equator, right? Tropic of Capricorn, Tropic of Cancer, right? Where a lot of you are from, right? this is a low latitude because the angle of insolation is always very high, meaning the sun is high in the sky all year long. Very little change in temperature. It's hot or warm all the time, meaning it's summer all year long. All right. Remind a lot of you of home. Yes. If not, right, that's where you would rather be than sitting in school, or in your case right now, not sitting in school. Right. Next, we have our high latitudes. So now we're referring to our polar or Arctic and Antarctic regions. Okay, very low angle of insolation. That's why they're so cold, right? And now there are big changes in yearly temperatures. It's very cold in the winter, and it tends to be very warm in the summer. Right? Here are your polar regions. Okay. Next, latitude and moisture. Right? So these are affected by the wind and pressure belts that are on page 14 of your reference tables. We actually took a look at these already. So low pressure, right? What do we know about low pressure? Well, low pressure, we have rising, warmer, and moist air. Where do we see that? Well, if we jump to our reference tables, page 14, right, here is a wet region, right? And we know that the air is going to be going up, right? Wet means that it's moist, and we know that the equator is going to be warm. Okay, so next we have high pressure. Our high pressure areas are going to be the opposite. The air is going to be sinking, cooler, and dry. So again, page 14 of the reference tables, here we go. Here is our driest, one of our drier regions. The air is sinking down. We can see these arrows are coming down, right, like this, right, making the air cooler, right, and as a result, very, very dry. All right, there we go. Okay. So we did mention, right, the high and low pressure latitudes. As we could see, we wrote these in our notes already. We talked about them. They're in our reference tables. Okay. Next, we have the prevailing winds. Well, that refers back to this chart. So how do the prevailing winds affect the overall climate? Well, first of all, a prevailing wind are winds that are going to blow over Earth's surface in the same direction most of the time. This can change, but most of the time they will blow in that same direction. All right? And I know I've asked all of you many, many, many times, where does most of our weather here in New York come from? Well, if we're looking at our map, we are going to look at page 14, right? We are located right about here, so we're going to have southwest winds generally, meaning if we want to know what our weather is going to be like tomorrow, we want to look southwest of us. So what causes these prevailing winds? Well, air pressure differences. When you have warm air and cold air, you're going to change the air pressure, and we know that wind blows from high pressure to low pressure. So unequal heating of Earth's surface. We know that there are places that are going to be warmer and places that are cooler. When we talked about this previously, we mentioned the beach during the day. What's going to heat up faster, the sand or the ocean? The sand heats up faster, therefore the air is rising and warm, low pressure over the land, right? And over the ocean water, it's cooler, it's sinking, there is your high pressure. The Coriolis effect. We remember this going all the way back to our earlier topic 4. Right? Coriolis effect is caused by Earth's rotation, and all winds are going to have a curved sort of appearance because of the rotation of the Earth. Bends to the right in the northern hemisphere and to the left in the southern hemisphere, also visible on page 14. Next, right? Skip those. Now, surface ocean currents. Okay, this is something that is completely new. This is going to be in your reference tables, right? And it is on page 4 in your reference table. So this map is page 4 of your reference tables, right? And when we look at this, if you live near a coastal area, meaning near the ocean, our temperatures are going to be affected by that ocean water. So when we take a look at this map, right, and I'm just going to jump to the map. So here is this map. And what I want to point out isn't the map itself right away. It's down here at the bottom. It's the key. All right, our warm currents are these dark arrows. The cool currents are these light color arrows. And when we take a look at this map to start, notice that all of our warmer currents are going to occur in this area near the equator. That's one of the warmest places on Earth, so that's going to have the warmest water. And when we look at our cooler arrows are going to start up north or all the way down south in our Arctic and polar regions, because that is our cooler temperatures. And then when you take a look at them all, they're all swirling around. Notice that the warm and cold are pushing each other out of the way. So if we have a cool current, right, they're going to flow from the poles to the equator with cold water. So we're going to go back to the map. All of our cool currents are coming out of this northern part of the Earth or the southern part of the Earth, and it's flowing towards the equator, right? Every single place. Cool current, right? Cool current, cool current, right? Cool current, cool current coming down like that. Cool current, right? Then it changes a little bit. Okay? So now, here they are. We could see our cool currents again. Now, the second ones are, I'm sorry, if you have a coastal area that has a cool ocean current near it, it's going to have cooler temperatures and less precipitation. That ocean water is going to stay colder for a longer part of the year, all right? For the winters, right? And then in the summertime, right, it's going to also stay a little bit cooler. Water takes a long time to heat up, right? A long time to cool down. And if it's cool, it's always going to be replacing that. All right. So it's going to have less precipitation because, as you remember, the cooler the air, the smaller the container of water, right? I held up many times in class the two different size containers. When you have something that's cool, it shrinks. It's going to be able to hold less water. Okay. Right? Then we move on to the warm currents. So our warm currents flow from the equator to the poles and have warm water. So if you live in a coastal area that is near a warm current, it's going to have slightly warmer temperatures and slightly more precipitation because that water is going to be warmer. It's going to evaporate a little bit more. Okay, a really good example of this, right? If we follow the Gulf Stream right up here, right, to this area, this is Ireland and England. Right? They are much farther north than we are. This is us here, and yet they have much more mild temperatures and a lot more rain than they should for a place that's so far north. Right? London is known for its rain. Same thing with Ireland. Okay, and now why does it have more precipitation? Because warm air can hold more moisture. You have that bigger container. Remember, when we have warmer air, the air is going to expand and hold more moisture. Next, and this is probably one of the more difficult ones to understand, right, is we have mountain ranges. So mountain ranges get in the way of the prevailing winds. They actually block the wind itself. All right. So where you would normally expect the wind to blow and have a certain type of temperature or moisture, when you put a mountain in the way, now that wind is forced up the mountain and down the mountain, and things are going to change. So we have two different sides. We have what is known as a windward side of the mountain. Right? This area is going to be cool and moist. So normally, what you'd have here is wind blowing off the ocean. There's going to be moisture in it. But now, instead of being able to just blow and flow across the land, it hits this mountain and it's forced upwards. What happens to the temperature of air as it goes higher on a mountain? It's going to get cooler. When it cools, it shrinks, you get condensation, right? And you're going to get rain. So the windward side of the mountain is going to be very wet. Right? This is Seattle, Washington. It rains quite a bit there, and the temperatures tend to stay a relatively cool all the time because of this sort of situation. On the opposite side now, and we can see the temperature decreases as you're forced up the mountain. squeezing that water out of the air. But now notice, once we come down the other side, as we go from the top of the mountain back down to land, the temperature is going to warm back up. But now there's no more moisture in it. So on the leeward side of the mountain, we have the opposite effect. We're not going to be cool and moist, but we're going to be hot or warm and very, very dry. All of the moisture was squeezed out over here, right? And then once the air crossed the mountain and goes down the other side this way, we can see the temperature warms up. So this almost makes it desert-like. So on one side, we have cool and wet. On the other side, we have warm and dry because of the mountain range. Right here we can see it, right, on our left side over here, we have, right, this is the windward. And I apologize, I don't know why it's doing that. And on the other side, we have the leeward side of the mountain. And my handwriting is terrible. I apologize again. Okay, so that takes us to the end of climate. I know it was very brief. I plan on attaching a couple of videos for you to watch after this so that you have a better idea. Also, do not be afraid to send me any messages, ask any questions. You can also take a look at the review material that I have posted on the files part of Teams. And again, feel free to reach out to me if you have any questions.